Welcome back to the Dish TV. I'm Rinita Malhotra Hora, Head of Marketing and Communications here at SRI International. And I have with me today Rakesh Kumar, also known as Teddy. He is a VP in our Information and Computing Sciences Division and Director of the Center for Vision Technology here at SRI. Hi, Teddy. Thanks for joining us on the show today.
Hi, Renita. Thank you for inviting me.
Can you tell me a little bit about some of the problems that are being addressed by CVT today?
The Center for Vision Technologies pushes the frontier of computer vision, machine learning, and AI to enable machines to see, understand, and remember. And we focus on real-world applications, often running in real time, including robotics, vehicles, and people-borne systems. We in CVT, what we pride ourselves is in being able to make full end-to-end solutions from sensing to high-level understanding using computer vision, AI, and machine learning, right? So starting from the camera and other sensors all the way to understanding what's happening in the world, both for single or multiple devices which are working independently.
What are some of the other problems being solved by CVT? Are they related to seeing better or quite different?
So another very big problem which we are solving is where am I and what is around me? So again, imagine you're a robot or imagine you're a person and we've equipped you with a camera and sensors. Then you want to know where is this robot wants to know where it is, and also what is around it so it can plan its movements. Similarly, for augmented reality kind of applications, you want to know. So we've developed a very accurate localization and mapping technology. Then one of these we call CamSlam, which is combining cameras with inertial devices. And it has a very low open loop drift, only about 0.1% error. That means you can go for 1 kilometer and it'll only be off by a meter. And then we match to landmarks or we get a global information to reset this to keep it even smaller than that. And so that's a very key piece of technology which we've developed, and we've used it in multiple commercial and government applications. We've used it for instances working with construction companies. Before the construction company built a building, at any stage they have a design document which says how should it be built. By using our navigation technology, they can overlay the design on what is actually being built and see how well it's lining up. Similarly, the construction company is also using this for moving material. When they do construction, a lot of time is spent on, say they're working on the 5th floor of a building. So the next day when they come in to work, they need all the material to be there on the 5th floor. And it takes a lot of time to move the material to the 5th floor before the workers can get to work. So we've been working with a construction company who've been building robots who can bring the material up automatically to the 5th floor, and they use our navigation technology to be able to bring it to the right place.
Where am I and what is around me? So with drones, that makes perfect sense. You know, they need to know that information with autonomous cars in that commercial setting as well. How about for real estate? Real estate, I mean, the nature of real estate is that I know where I am, right?
So what we've also licensed the technology to Rescan, which is another spin-out from SRI. And Rescan is using this technology for mapping real estate so that they can then be able to sell real estate virtually. So someone can take a tour of a real estate virtually. So they use our software to be able to map a mall or any other large hospital, any other large real estate area, and then use that to provide remote visualization.
A short while ago, we had spoken with Bill Mark on this show, and he had said that the ICS division in general was doing a lot of work in human-computer interaction. I'd love to understand your perspective on the Center for Vision Technology's contribution to this area.
Yeah, that is a very big area for us in the Center for Vision Technology. And we've been developing a technology which is comprehensive, real-time human understanding, and then use that to do human-computer interaction. And we do it in a multimodal way. So not only are we listening to the human's voice and trying to understand what they're saying, but we also trying to understand their gestures, their posture, their pose, their facial expressions. So we're doing this in a complete multimodal way, and we've been using it for various government and commercial applications.
Again, like what? Why do we need to study this kind of behavior?
So the best way for me to answer that question would be talk about a driver monitoring system which we developed, which utilizes a suite of cameras, both infrared cameras and 3D cameras, to monitor the driver's body. It monitors driver's eye movements, facial expressions, general body language. And we are trying to identify the driver's emotional states and also drowsiness level. The most current systems rely solely on eye tracking and facial expressions. We also consider body language. And we received an award for this technology in 2020, the Autotech Award. And also this system had been integrated into Toyota's LQ concept car. The goal of the system is to identify the driver conditions that might lead to accidents and then allow the vehicle to take proactive steps. So, for instance, if there's onset of drowsiness, before the driver falls asleep, you want to take actions to warn the driver they're about to fall asleep, or understand negative emotions like road rage and anxiety. So then again, before they do something foolish or something, we can try and help them or ease them.
Teddy, what would you say is the future vision for the CVT group now, this year, or, this year going into next year?
So one of the big areas we've been working on is collaborative autonomy with semantic understanding. So imagine instead of one human controlling one robot or one drone, a human is controlling 50 robots. So what we want is now the robots to be able to take high-level direction from the human, and then all of them can do their own tasks. So they are doing a lot of autonomous tasks. They're between themselves or deciding who's doing what. And the human is only giving high-level direction. So this is an area, what we call collaborative autonomy, where humans and robots are working together. A few humans are controlling lots of robots, and humans can control the robots with natural commands. You can just speak to the robot just like we're speaking to each other, and the robot's able to understand those high-level commands in the context of what it needs to do and figure out what it needs to do. Another very big area is low-power machine learning. So we've been developing a set of technologies called Neuro Edge. One of the new exciting technology trends is IoT, Internet Things devices, where you can put sensors all over the place, and these are very low-power sensors. Even your remote control on your TV has a computer now. And so when you have these sensors scattered all over, you want to have machine learning on it so the system can adapt over time. And this needs to be very low power. You don't want to change the batteries in your remote control. And so we've been developing this machine learning at the edge where you can do very low power AI. And that's a very nice big area for us.
So if I come in as a newbie, into the Center for Vision Technology, do I need to come in with an area of expertise so that you can match me with biosciences or ATS or something like that? Or can I pick? How does it work?
We are typically looking for people with AI, machine learning backgrounds. So those backgrounds can be applied to all these different problems. So we're not necessarily looking for people who have a background in AI and bio, AI and education. We're looking for the more general background. And then we have a lot of projects. I have a group of about 90 people, and I have about 50 projects. So you get exposed to a lot of stuff. And over time, you'll get the opportunity to work on lots of different things. And then you can also say that this is the area you want to work on, and we're always looking for people to take us in new directions. So you can also sort of set your own agenda.
So it sounds like vision is important, not only from that single sense point of view, but because it affects so much else around us. Is that right?
Yeah, that's right. If you think about the human brain, 50% of the human brain is working on vision.
50%. I did not know that statistic, but it makes perfect sense. All right. Thank you, Teddy. Thanks so much for joining us today.
Thank you for inviting me.